So now we need to sort of look a bit about muscle mechanics. How do these work? And we said how the muscle fibers work in the last chapter. But we didn't talk about the fact that there are actually different muscle types. But maybe you can already understand that, because some muscles need to go for long duration and other muscles just need to be able to give you a burst of energy quite quickly. So we have got different muscle types, and anybody who has ever tried running knows they are either a sprinter or more of a long distance runner, or you might feel you're not a runner at all, and that's a different thing. But people who run marathons are very different to people who run sprints, do the 100 meters, and the training that you do is different because you're building up different types of muscles in your body. There's also an issue of if we stretch a muscle more, we'll get more power from it. That is just a rule that we see in all muscle. If you stretch it, you enable more of the myosin heads to get onto the actin, and that is really important. Obviously, you can overstretch it so that none of the myosin can touch the actin. You don't want to do that, but if you stretch our muscles out, we stretch the sarcomeres a bit and enable each to do a more powerful stroke. You can get more actin and myosin touching if you've stretched first, which is so important for athletics and people who are student athletes. Recruitment, that's the business of motor units. Depending on the number of motor units within the muscle that you're using will depend on the power that you have and the force you can use from one particular muscle. So recruitment talks about motor units. Are we using all of our motor units, in which case you're getting the most force you can, or are you using only the smaller motor units to get the force? Really what we want to focus on here is fascicle arrangement and the lever system. And if I don't know, you may say lever, you may say lever. I've had people laughing at me in class for my pronunciation of lever, but that's very much the British pronunciation. So let's look at fascicle arrangement, and then we can talk about levers. So you've probably seen that muscles come in different shapes and sizes. We have circular muscles, and we're going to learn two of those. We have one that goes around our mouth called the orbicularis oris, oris for oral, mouth. Orbit, it means orbicularis. So you can see orbit there because it orbits the cavity, the whole of the mouth, and that allows us to pucker our lips, because when it contracts, it makes the hole smaller, means you can pucker to kiss, and that is the orbicularis oris, and also closes the mouth. We also have orbicularis oculi, which goes around our eyes in a circular fashion, and that's also going to close our eyes. A really important arrangement for fascicles, because basically that is any sort of sphincter that we have in the body. Sphincter is an important word because basically it is those circular rings of muscle that close off all those tubes, so that when you don't want to poop or pee, you close off the tube and don't poop or pee in an inappropriate place, because circular muscles or sphincters are holding those tubes closed. So it's a very important fascicle arrangement, the circular one. Convergent allows lots and lots of muscle fibers to go to one point. So it enables you to get a lot of power in the muscle, because the number of muscle fibers allows for power. Fewer muscle fibers, less power. More muscle fibers, more power. Sort of makes sense. Fusiform is another way to get the muscles arranged, and that would be like the biceps. It allows for the muscle to have a bigger bulk, so we can get hypertrophy of these muscles more easily. It's a bit difficult to get hypertrophy of circular muscles, but we can get more power because we can grow bigger muscle cells in a fusiform arrangement. The parallel form, these are the long muscle fibers that I've spoken of. The sartorius is the one that goes from the lateral hip to medial knee that I've talked about in class. It's very long, but what that allows you to do is get a big range of movement. It's not a very powerful muscle because we don't have as many muscle fibers pumped into this space as we do for a convergent muscle, but because it's going over a long distance, it can bring the movement through a lot of distance in a short space of time, and that gives us speed. And we'll talk about that in a moment. The next one will be pennate and bipennate and unipennate, and this is just a way of getting more fibers packed into a particular area. Because if you look at this unipennate muscle and compare it to the sartorius muscle, they look as though they're going to take up about the same amount of space. And they do, but here I have masses and masses and masses of short fibers, giving a lot of power, but I can only move them over a little distance. With a muscle arrangement that is in parallel, like this, I have fewer muscle fibers but going over a longer distance, so I can get that distance over time, which is speed, but I don't get a lot of power. Whereas for something like a unipennate muscle, I don't get much distance, but I get a lot of power. So I don't get speed, but I get power. And that's multiplied many times over in a bipennate or a multipennate, but these obviously take up more space than a unipennate. So they're designed for power. So the arrangement of the fascicles determines the muscle's speed of motion or the muscle's power. If we have long fibers that are more parallel to the long axis of the muscle, these are going to allow for a lot of shortening, which usually gives less power but more speed, more fast movement. And the power is going to depend, the power that we can get out of a muscle is going to depend on the number of muscle fibers. If we have a lot of fibers, we get more power, but they tend to be shorter, as I've just said, in the bipennate, multipennate, unipennate structure. So I'll come back for another video on levers.